Okay, so welcome to this tutorial on critical path analysis, and we'll get straight in with an exam question taken from the June 2013 Decision Maths part of Use of Maths. So in this question we're dealing with an author who's writing a book, and we're given this precedence table here which gives us a list of the activities as well as which activities must go before these and how long that each one will take. And our first question in part A asks us to construct an activity network for the project. So I'm just going to do a rough sketch first to get an idea of what shape it's going to take, and then I'm going to draw it out properly. So looking at activity A first, we see that A has no immediate predecessors, so I'm just going to put an A there for now. Now looking at B, well, we see B and C both depend only on A. So I can show that with some arrows, B and C. Then D depends on both B and C. Something like that. Now the next one, a bit more complicated, E, F and G all depend on the same activity, D. So we're going to have three arrows coming off this time, trying to spread them out a little bit. E, F and G. So you notice that activities that happen after earlier ones must be written to the right, but activities that can take place at the same time, like E, F and G, can be written in a vertical line. So back to the precedence table. We've covered E, F and G, so now down to H, and we see H depends on E, F and G. And then both I and J, they both depend on H. And finally, K depends only on I and J. So here we have a rough sketch of what my activity network is going to look like. Obviously this lacks a lot of detail, but now I'm ready to draw a proper one using the familiar boxes with the space to fill in the numbers. So here's one I prepared earlier. You'll notice it's got exactly the same layout and structure as the one on the previous slide, but this time I've got the space on the boxes so I can fill in the values. Now the middle box in each of these, that is for the duration, which we're given in the precedence table. So A has duration 4. B has duration 3, C has duration 5, D has duration 2, E is 1, F is 1 and G is 2, H is 1, I is 2, J is 1 and then K is 2. So here I have my completed activity network now. Now the next thing the question asked me to do was to fill in the first and last boxes here by doing first of all a forward pass to find the earliest start times. So we start with A. Now the earliest A can start is obviously at time 0. Now if A starts at 0 and it takes 4 weeks to complete, that means the earliest that B can start is 4 weeks, and also the earliest C can start is 4 weeks. Now when we move across to look at D, we see that D depends on both B and C, so we need to consider each of these. B can start after 4 weeks and takes 3 weeks, so D could start after 7 weeks. However, C starts after 4 weeks and takes 5 weeks, and so that would mean that D would start after 9 weeks. So we have to take the larger of these values, as D can't start until both of these activities have been completed. Now looking at activity D, D can start after 9 weeks and it takes 2 weeks, so each of the activities that depend on it would start after 11 weeks. Now looking across at H, H depends on 3 previous activities, so let's look at each of these. E starts at 11 and takes 1, so it could be 12. F starts at 11 and takes 1, so again could be 12. G starts at 11 and takes 2 weeks, therefore making 13. So we take the largest of those values to make H start at 13 weeks. So H starts at 13, it takes 1 week, so each of the activities that depend on it can start after 13 add 1, 14 weeks. And finally K could either start after 14 plus 2, 16 weeks, or 14 plus 1, 15 weeks. We have to take the larger, as both activities have to be finished. So K can start after 16 weeks. So when we do a forward pass, then, we always have to take the larger of the two possibilities. Next, to fill in the last box, we need to do a reverse pass to find the latest finish time. So if K starts, so this time we start from this end, and if K starts at after 16 weeks and takes 2 weeks, it'll be finished by 18 weeks. Now, working backwards, if K has to be finished by 18 weeks and it's taken 2 weeks, then both of these activities must be finished by 16 weeks. Now, H has to be completed before either of these two activities. So if I finishes after 16 weeks and it takes 2 weeks, that means H might be finished after 14 weeks. But J has to be finished by 16 weeks and it takes 1 week. So H would then have to be finished by after 15 weeks. Now in this case, going backwards, we take the smallest case as it has to be finished before either of these events can start. So working backwards again, H has to be finished by 14 weeks. It takes 1 week. So each of these activities must be finished by 13 weeks. Then D could be 13 minus 1, 12. 13 minus 1, 12. 13 minus 2, 11. So working backwards, we always take the smallest possibility. 11 minus 2, this one has to be finished by 9 weeks, so does this one. And then 9 minus 3, 6 weeks, or 9 minus 5, 4 weeks. Again, taking the smallest. So now here is my activity network fully completed with both the forward pass and reverse pass done to find the earliest start and latest finish times. The next thing to identify is the critical path. To do that, we're going to look for activities that don't have any float. So if we look at A starts at time 0, it takes 4 weeks and it has to be finished by 4 weeks. There's no space in that time frame, so A is critical. B starts at 4 weeks, takes 3 weeks, which makes 7, but only has to be done by 9 weeks. So this one has a float of 2. C starts at 4 weeks, takes 5 weeks, which makes 9 weeks, which one has to be finished. So C is critical. D, 11 minus 2 minus 9 gives me 0. So D is critical. E, 13 minus 1 minus 11 gives me a float of 1, not critical. F, 13 minus 1 minus 11 gives me a float of 1, not critical. G, 13 minus 2 minus 11 gives me 0, so it's critical. H, 14 minus 1 minus 13, 0, so it's critical. I, 16 minus 2 minus 14 is 0, so I is critical. J, 16 minus 1 minus 14 gives me a float of 1, so it's not critical. K, 18 minus 2 minus 16 is 0, so K is critical. So my critical path then is A, C, D, G, H, I, K. So I found my critical path. Final thing that I've been asked to do for this question was to then draw this on a Gantt diagram. So here's my grid for my Gantt diagram, and I've also got my activity network up here. I'm going to start by just labelling some values on my axes. I see that everything's all done by 18 days, so I think my axes should go up to 20, 5, 10, 15, 20. And I'm going to start by putting my critical path along the bottom. So A starts at time 0 and it goes up to time 4, That is event A. C starts at 4 and goes up to 9. There's 9. That's event C. D starts at 9 and goes up to 11. There's D. G, 11 to 13, which goes there. H starts at 13 and goes on to 14, which is there. I starts at 14 and goes on to 16. And finally, K starts at 16 and goes on to 18, which is there. So I've now shown all my critical activities. There just remains to put in the rest. So first off, B I see starts at time 4. And it goes on for 3 weeks. So it can be finished by 7 weeks. So I draw a solid box for that time period. But because B could actually finish anywhere up to 9 weeks, I'm then going to dot up to 9 weeks like that. And that shows the float time. Then both E and F can start at time 11. They take 1. So I draw a solid box up to 12. There's E. And it has a float of 1 as well. So we'll have a dotted line there. F I can't fit in here as well, so F will go on top. Again with a solid line there. And a dotted line showing the float. And that leaves me just J. Now J starts at time 14. It goes on for 1, which takes us up to 15. But it can go on any time up to 16, showing again it has a float of 1. And there is my completed Gantt or cascade diagram, and that brings that topic of critical path analysis to a conclusion.